students. You are welcome to FGGCBWR online lesson series. My name is Fggc, and I am here to take you chemistry, particularly for the SS2 class. Even though you are in SS3, you can still come forward. You can also benefit from this, and if you are planning to write JAM or YEC, you can also still benefit from this. So like I said, the topic before you is acid-base reaction. Before now, we have treated a topic known as a mass-volume relationship, also known as stoichiometry. And I believe we have a very good understanding of that topic, because a lot of things we are going to be discussing now will be captured from that. Now, when we talk about acid-base reaction, we cannot discuss it effectively without, first of all, mention a very important technique known as volumetric analysis. And now, what is volumetric analysis? As you can see on the board, volumetric analysis can be defined as the accurate measurement of a volume of the reacting substances. These substances are always in the form of a solution. To make it short, or in summary, volumetric analysis can also be defined as the titration of acid against a base. And of course, this is what we call neutralization reaction in chemistry. That is a reaction between an acid and a base to form a salt and water. As you can see on the board, we have hydrochloric acid reacting with sodium hydroxide to give us a salt, sodium chloride, and water. Now, there are some important terms. That is associated with volumetric analysis. Those terms are as follows. One, we have the standard solution, we have the mass concentration, and we have the molar concentration. Now, what is a standard solution? A standard solution is a solution of which the concentration is known. And how do we prepare this standard solution in the lab? It can be prepared by weighing a pure solute. A pure solute, maybe, for example, we have a solid of sodium triazocarbonate 4, as you can see here, and you weigh it using the weighing balance. Sometimes we also call it the chemical balance. Now you get a solute of this, and what do? You dissolve it inside a suitable solvent, usually water. And you are going to what? To dissolve it, making the solution up to a definite volume in a volumetric flask. As you can see, this is the volumetric flask. And we normally use this because this is a flask that is being used to give us an accurate measurement of whatever solution you want to measure in the lab. And when we talk about a standard solution, we said, for example, a solution known to contain exactly 10.6 grams of anhydrous sodium triazocarbonate 4 in 1 decimeter cube of the solution is a perfect or a very good example of a standard solution. Now, the second one is mass concentration. Mass concentration can be defined as the amount of solute present in a given volume of the solution, and it is usually expressed in grams per dm cube. Then we have the molar concentration. The molar concentration can also be defined as the amount of solute, or the number of moles of solute present in a given volumes of a solution. And this is also expressed in a mole per dm cube. Now we are going to be looking at the relationship that connects the mass concentration and the molar concentration. The first relationship here, or the formula that connects the mass concentration and the molar concentration here is, one, we have the molar concentration, which is in mole per dm cube, equals to mass concentration in gram per dm cube over the molar mass, which is in gram per mole. And then the second one is N, small letter n, equals to CV over 1000, or N equals to CV, where the small letter n stands for the number of moles, and then the C here stands for molar concentration in mole per dm cube, while the V here stands for volume in decimeter cube or centimeter cube. And the third formula here, we normally refer to it as a mole ratio, the mole ratio formula. Some people will call it the Carver formula. Okay, we have it as CAVA over CBVB, which is equals to NA over NB, where the CA here stands for concentration of the acid in mole per dm cube, and then we have the VA, which is the volume of the acid in dm cube or centimeter cube, and then we have the CB, concentration of the base in mole per dm cube, and then we have the VB, volume of the base in dm cube or centimeter cube, and then we have NA, which is the number of moles of the acid, NB, number of moles of the base. And then the fourth method here is called the dilution method. The dilution method. We have it as C1 V1 equals to C2 V2, where C1 and C2 stands for initial and final concentration in mole per dm cube, and then V1 and V2 stands for the initial and the final volumes in the dm cube or cm cube. Okay, at this point in time, I want us to look at some problems, some calculations, using the following formulas I have listed for you on the board. Let us identify some problems, see how we can solve some problems using those formula. As you can see on the board, we have a question which says that calculate the mass of sodium thiazocarbonate 4 present in 300 cm cube of 0.1 mole per dm cube, where the mass number of sodium is given to us as 23, mass number of carbon 12, and then the mass number of oxygen 16. Now, first of all, we write our solution, and then we are now going to extract our data or our parameters. So we are starting with, in the question here, we are asked to find the mass of this compound, sodium thiazocarbonate 4. Now we'll write the mass of Na2CO3. Of course, this is what we are asked to find, so we don't know. We can represent it with a question mark. And then, in the same question, we said we are given a molar concentration. We are given molar concentration. Molar concentration to be what? 0.1 mole per dm cube. And now, in this same question, we are given volumes. We are given volume to be 300 cm cube. And we also have molar mass. Molar mass, although we can figure it out, we can determine the molar mass from the following figures here. Now we are given the compound here is sodium thiazocarbonate 4, and for us to get the molar mass of this, first of all we are going to sum of the mass number of each of these elements present in the entire compound. That will give us the molar mass. So we have it as Na2. Sodium here is given as the mass number is 23, but sodium has 2 atoms. So you multiply 23 by 2. Plus, you have the carbon, which is given as 12 as our mass number. Plus, we have oxygen, which is given as what? As the mass number is 16, multiplied by the 3 atoms. And then you sum everything up. Clearing the bracket, we have 46 here, plus 12, and then plus 48. And this will give you a total sum of 106 gram per mole as our molar mass. So with this, I know we have the volume here given to us as 300 cm cube. This will come up later because we are going to use the first formula, which says that molar concentration equals to mass concentration all over molar mass. Now, looking at the parameters here, you can see that molar concentration is given to us. Molar mass is also given to us, except for the mass concentration. Therefore, we will now make the mass concentration our subject formula. Therefore, we have it as mass concentration equals to molar concentration times molar mass. That will now give us our molar concentration here. As you can see, we have 0.1. So we have it as 0.1 multiplied by the molar mass, which is given to us as 106. Therefore, our mass concentration is now equals to 0.1 multiplied by 106. You can use your calculator. And that will give us 10.6 gram per dm cube. It has not finished now because we have to make use of the volume that is stated in the question, because we haven't applied this yet. So we will now apply what is called the proportionality method. We now say, now (1,000 cm cube of the compound contained the amount we got here, which is 10.6 gram per dm cube. Therefore, from the question, we are given volume to be 300 cm cube. So you are going to represent it here, you bring it here, which is 300 cm cube of the same compound, sodium thiocarbonate 4, will contain X. Will contain X of this gram per dm cube, and that will give us X is equals to, that will give us, you cross multiply, that will give us 300 multiplied by 10.6, you divide it by 1,000. When you do that, you use your calculator. When you do that, you get 3.18 gram per dm cube of Na2CO3 is what is going to be formed. You can also use the second formula, which says N equals to Cv over 1,000. Yes, we are using 1,000 here. Instead of, I gave you two formulas. It's either Cv over 1,000 or N equals to Cv. But now, I choose to use Cv over 1,000 because in the question, we are giving an initial volume as 300 cm cube. So you have to take note of the units. Okay, so if you are using cm cube, you know that you are using this formula. But if the question is not giving you a volume, okay, of cm cube, you can use the other formula, which is cv. You know, that is for the decimeter cube. So now we'll go by this formula, and then we have it as n. Our n now, where we said our n is equals to what? Number of moles. Number of moles. And we have our c, which is equals to concentration. That is the molar concentration in mole per dm cube. And then we have our v, which is equals to our volume. Now, looking at this question, you will now find out that we have our n not known in this question. We have our n not known in this question, but the value of c here is given to us. It's given to us as 0.1 mole. So therefore, we have our c, n equals to this. So we are going to have 0.1 multiplied by the volume, which is given to us as well as 300 cm cube. 300. So we divide it by the 1000. Therefore, our n is going to give us 0.03 mole. 0.03 mole. That is not all. Now, from one of the formula of moles, we also know that mole is equal to what? M over RAM. RAM here stands for relative atomic mass. So relative atomic mass of the compound sodium carbonate 4. Now from here, already we have known the value of N and the value for our RAM. I think we have calculated it somewhere before to be what? Our RAM here is calculated to be 106 gram per mole. Therefore, for us to know our mass, we are going to cross multiply, make N subject formula. That will give us M equals to N times RAM. Therefore, our M is equals to the N, which is the value here. We have it as 0.03 multiplied by the RAM, which is 106. And that will give us M. That will give us the same value here. That will give us the same value we got, which is 3.18 gram per dm cube. Okay, now we are going to be looking at example 2, and the question says, calculate the volume of 0.25 mole per dm cube solution of H2SO4 that will contain a mass of 4.5 gram of the acid. Now, as you can see, we have the molar concentration to be given to us as 0.25 mole per dm cube. The molar mass of H2SO4 of this compound, which is also known as the RAM, can be determined as 1 times 2 plus 32 plus 16 times 4. And this will give us 2 plus 32 plus 64. When you sum this up together, it's going to give us 98 gram per mole. Now we are to find the mass concentration. So using the first formula also, the way we did for the first one, now making this mass concentration our subject formula is going to be mass concentration equals to molar concentration times molar mass. doing that, we are going to have our molar concentration to be 0.25 multiplied by the molar mass, 98. So when you punch your calculator, you are going to have 24.5 gram per dm cube. That is not all. Now apply the proportionality method. You have it as, now 1 dm cube of H2SO4 is contained in 24.5 gram per dm cube. Therefore, we now have our x dm cube, which we are looking for, of the same compound H2SO4, will contain, from the question, we have 4.5 gram, will contain 4.5 gram. And when you cross multiply, our S is going to be 1 times 4.5 divided by 24.5. Therefore, our X will be, use your calculator, our X will be 0.184, approximately 184 dm cube, or 184 cm cube. That is, when you are trying to convert from dm cube to cm cube, you multiply the value by 1000 to give you this. Also, you can use the formula that says N equals to CV. And from there, we now have it as N is equals to our CV here, our C here. From the question, we have 0.25 and 0.25, and we have our, we have our N. N is also equals to what? M over RAM. And that will give us, from the question, our mass here is 4.5 divided by the RAM of H2SO4, that will be 98 grams. That will give us, using your calculator, we are going to have, 0.0459. 0.0459 moles. Therefore, our C, we have it as 0.25 mole per dm cube, as you can see it here. And then we also have our volume. Our volume, of course, is what we are looking for. So we are going from here, from the formula that says N equals to CV. We are going to make our volume subject formula. By doing that, we are going to have it as V equals to what? N over C. Therefore, our V will be equal to the moles, which is N. We got 0.0459 divided by the concentration. The concentration, which is 0.25. So when you punch your calculator, you are still going to get the same value. You are still going to get the same value as 0.184 dm cube, which is or 184 cm. Okay, again we have another example here, example 3. This has to do with the number of mole of that is the mole ratio formula, also known as the cover formula. Now the question before us says 20.30 cm cube of HCl solution was titrated against 25 cm cube of 0.1 mole per dm cube. of sodium hydroxide solution. Now we are given two questions to calculate. The first question says calculate the concentration of the acid in mole per dm cube, and the second one says the concentration of the acid in gram per dm cube. First and foremost, in a question like this, what you need to do is to make sure you bring out the equation for the reaction. And the equation for the reaction is given as a, because this is a neutralization reaction where acid and the base react together to form a salt and water. So this will give us a HCl plus sodium hydroxide to give us sodium chloride and water. Now, after writing the equation, the next thing you are to consider is to make sure that the number of the moles for the acid, the number of the moles on the side of the reactant and on the side of the products are equal. And looking at this, we are going to want to check the mole ratio here. The mole ratio for acid to base. You can see that here nothing is written here. It means for the acid, hydrochloric acid has only 1 mole into ratio. And the same thing to the sodium hydroxide, it has nothing here. It means it is also what? 1 mole. Okay? And then with this, you can now go forward to what to extract your parameters from the question, where we have our Ca. Our Ca is the concentration of the acid we are asked to find. We don't know it, we represent it as a question mark. Then we have our Va, which is the volume of the acid. Now looking at this, we are given 20.330 cm cube of a HCl. Of course, this is the volume of the acid, 20.30 cm cube. And then we have our Cb, which is the concentration of the base. And the concentration of the base in the question here is given as they said titrated against 25 cm cube of this. Of course, this is the concentration of the base, 0.1 mole per dm cube, while the volume of the base is the 25 cm cube. And then the number of the acid we have just figured out from the reaction is 1, and then the number of the base is also 1. So with this, we can now bring out our formula that says CAVA all over CBVB equals to NA over NB. Now, making our CA subject formula, because that is what we are looking for, then we have it as CA equals to CBVB NA over VA NB. And that will give us bringing it up here, we are going to have it as substituting with the given values now. We said our Ca is equals to our Cb from the data here. We have it as Cb, we have it as 0.1 multiplied by Vb, which is the volume of the base, as 25. And then we have the Na, number of the acid, which is 1. You divide it by Va, which is the volume of the acid. Va, which is the volume of the acid, is given as 20.30 multiplied also by 1, the number, the Nb. Therefore, our Ca is equals to, when you punch your calculator, you are going to have it as 0.123 mole per dm cube. And then the second aspect of the question, B, which says that calculate the concentration of the acid in gram per dm cube. Now, concentration of the acid in gram per dm cube. From the formula we have been using, making concentration of the acid in gram per dm cube a subject formula that will give us concentration of the acid, concentration of the acid. Okay, let me use the acid HCl equals to the molar concentration of the HCl times the molar mass of HCl. Molar mass of the HCl. That will give us the molar concentration of the HCl. Molar concentration of the HCl, that is what we just calculate. We have it as 0.123. But what about the molar mass of the HCl? How do we determine the molar mass of the HCl? As usual, you have it as RAM of what? Of HCl. And that will give us hydrogen will give us 1 plus chlorine. The mass number for chlorine is 35.5. And that will give us 36.5. So you now multiply this by 36.5. That will give us equals to, using your calculator, we are going to have 4.5 gram per 4.5 mole per dm cube, approximately 4.5 mole per dm cube. Okay, 4.5 gram. Sorry, we are talking about the mass concentration. That is mass of that 4.5 gram per dm cube, approximately. That is what we are going to get. Okay, now as you can see, we have the last example on the board, and this last example has to do with the last formula, which is known as the dilution formula, which states that C1 V1 equals to C2 V2, where our C1 is given as 0.20 mole per dm cube, and we have our V1, which is equals to 5.00 cm cube, and we have our C2, which is what we are looking for, because the question says what is the concentration of the resulting solution. That is what we are looking for. We don't know it. And then we now have our V2 to be equals to 250 cm cube. Therefore, making C2 subject formula, we have it as C2, which is equals to C1 V1 over V2, and then our C2 is equals to, now we are going to substitute with the given values. Our C1, we have it as 0.20 multiplied by V1, which is 5, divided by the V2, which is 250, and then C2 is equals to, when you simplify this in your calculator, first of all, you have this as 1 over 250. That will give us C2 0.004 mole per dm cube. As you can see, the examples we have given so far have covered all the formulas I have stated for you earlier. Right now, I would like to give you some questions to practice. So please, I want you to take your time and go through them and try to see how you can answer them very well. And please, do not hesitate to drop your question on the comment section. So the assignments are as follows. "25 cm cube of 0.1 mole per dm cube of H2SO4 are required to neutralize 20 cm cube of sodium hydroxide NaOH solution. Calculate A, the molar concentration of NaOH, and then B, the mass concentration of NaOH. And then question 2. Question 2. What volume of 2.5 mole per dm cube KOH potassium hydroxide will be diluted with water to obtain 250 cm cube of 2 mole per dm cube. So please, I want you to find time and go through what I have just finished doing with you now, and please try to answer the 2 questions given to you on the board. In summary of all that I have been saying, okay, we started with acid-base reaction as a topic, and of course I have told you the meaning of volumetric analysis. I have given you some of the terms, some of the important terms that are associated with the volumetric analysis, such as the standard solution, the molar concentration, and then the mass concentration. And then the formula that connects this together, I have given you 4 different formulas. So please, I want you to take your time and go through this very well and try to solve the assignment given to you. And please, like I said, do not hesitate to drop your question on the comment section. Thank you. God bless you. We meet next.